Greetings and welcome to Flanigan's Ecologic. I am your host, Ted Flanigan, and I'm excited to have Bill Browning on the podcast today. Bill is somebody who I worked with at Rocky Mountain Institute years ago. He went on to create the green development services there. He then formed Terrapin Bright Green, and we're going to be talking about his company that he founded and he's been running, and all about biophilic design and harmonizing our built environment and the natural world and our senses. Happy to have Bill on the show today. Hey, Bill, welcome to the podcast. How you doing?
Happy to be here. Good to see you.
Really, really good to see you. And you mentioned you're in Washington, D.C. these days, right?
Yeah, I've been here for a few years now.
And the first snow, I guess right?
Yeah, first snow in over 2 years. So kind of fun to see 4 inches. Got all my Colorado gear out, my Sorels and layers, and went out and shoveled early this morning.
Are you getting any skiing in these days in your life?
It's been a while. It's been a while.
You were I mentioned in the opening, I'm going to introduce you that we worked together at Rocky Mountain Institute, and you are an incredible skier, I remember, and an avid skier. So yeah, anyway. Good stuff.
Little out of practice, but hoping to get back out there sometime soon.
Yeah, me too. So what are you working on? I've introduced you as the head of Terrapin Bright Green. What's on the docket today?
So, well, Terrapin is a small research and consulting firm. And so we do advanced green building strategy stuff. We do sustainability policy work. But a lot of our work focuses on kind of 2 areas that we're passionate about. One is biomimicry, literally, how does nature do that? And the other is biophilia, human connection to nature and how that impacts us psychologically and physiologically. And so a lot of our work is sort of framed in those areas. The sustainability work we're doing is increasingly moving into the realm of regenerative design, literally, saying, okay, let's move past just net zero. As Janine Benyus says, nature doesn't do zero. Let's really think about how we move into restoration and much more interesting realms. And that's where a lot of our biomimicry work is at this point. We ran a project for 5 years for the state of New York of working with industries in the state, funded by the New York State Energy Research and Development Authority, NYSERDA, to help solve industrial design or process issues that traditional engineering wasn't doing, and could we find something in nature that was doing it better? And we wound up working with 15 companies and raising about $5 million in proof of concept funding through the project. We kind of shifted now more to thinking not about sort of individual objects in biomimicry, but more ecosystems. And literally doing projects where we are looking at what can the ecosystem tell us about how we should be designing these buildings and operating these operations. So that gets into questions like, all right, so if this site was an intact example of a local ecosystem, what would it be doing? What would the carbon balance be? How would it be dealing with water? What would the nutrient flows look like? What would the biodiversity look like? And those are all things that we can measure. And so we come up with a set of performance standards based on a unit area like acreage or square feet, and then say, okay, the local ecosystem would have done this, so that should be our goal. And so that's past zero, right? That's not net zero energy. That's moving past that.
What's an example of that? Bill?
Well, one of our biggest examples of that was a project with Google on a massive building in Manhattan, contained almost 3 million square feet. It was built as a warehouse by the Port Authority around the same, almost exactly the same time as the Empire State Building. It was only 16 stories tall, but it covered an entire New York City block, sidewalk to sidewalk. And so trucks came into this building, trains came into the building, trucks were put on elevators and taken up and down through the building to make their deliveries through the building. I mean, these elevators are the size of freaking ballrooms, right? It's just incredible. And so our client bought this building and started putting tenants in it. And by the time we got to the building, there were 1 million square feet of data centers in the building, and various offices and other uses in the building. And because the base building really didn't have had a minimal mechanical system, each tenant then had their own mechanical systems. And so the roof of this building was completely covered with equipment, and so much so that there was no room for anyone else to put more equipment up there. And so tenants that wanted to expand their uses couldn't because of this constraint. It also had the biggest energy bill in New York.
Yeah.
$53 million of electricity a year in one building. And so, you know, the question from our client was, okay, you know, how can we address it? How can we think through this issue and help our tenants expand, but also deal with this, you know, this huge amount of energy use? Oh, and by the way, while you're at it, we also have a weird issue with the water's use in the building. It's like, okay, what do you mean by weird? And they're like, well, so we buy 51 million gallons of water a year from the New York water system, and we put 90 million into the sewer. And it's like, okay, the physics of that don't quite work out. You know, if we look at rainfall, you know, if we absorbed all the rainfall of a building, that would only be another 5 million. So where's that 45 coming from? And so doing some investigation with them under the building, under the parking decks, under the building, in the lowest sub-basement, under that was a sump with 3 huge pumps that have been running pretty much continuously since the 1930s. And we looked at the water, and it was, you know, we thought, well, we're near the Hudson, so, you know, it's so deep that maybe, you know, we're getting water from the Hudson. No, it was clear, fresh, pure water. And it wasn't city water. It was one of the original streams in Manhattan. And so, and the way we confirmed that was we were working with the Wildlife Conservation Society on a project called Mannahatta that remapped all of Manhattan back to the ecosystems at the point of European contact. And so you can type in an address and see what ecosystem would have been on your site. And sure enough, we had a forest, and in the middle of that forest was this stream that had, since the building been built, been pumped out of the basement and put into the sewer. So that made us ask, what else, you know, was this ecosystem doing? And so we ran a set of numbers, and one of those numbers was the site would have been sequestering 3.7 tons of carbon a year, when its current balance was 85,000 tons of carbon a year. While we were doing all of this, one of the tenants in the building, Google, bought the building and came to us and said, we're really interested in what you guys are doing. We really like aspirational standards, and we realize if we say, oh, we want to cut the energy use by 30%, that's just not going to motivate people here. We need something really aspirational. And so we developed it with them, a set of performance metrics based on what the ecosystem that site would have been doing. And so the long-term goal is to move towards a water balance that looks like the water balance the site would have had originally, a carbon balance that looks like a carbon balance. And so when you have questions like that, it pushes you to think about and keep asking questions beyond what you would normally do. in a design or sustainability process and gives you long-term goals to keep moving towards. And so for us, it's also getting at this idea of regenerative design, where it's not just notional, oh, I'm doing something really great and helping the environment, but I can actually measure my progress of, am I getting there? Is the biodiversity coming up? Is the water balance getting better? What's the carbon look like? And so that's work, and it's unusual because normally when you do a project with Google, you're not allowed to talk about it. But this is one that actually we have jointly publicly presented with Google in conferences and forums.
Well, is there just a direction now, or are there specific steps that they took? Is there more?
Yeah, there have been. Well, there are other tenants still in the building, and as the leases roll for those tenants, they take over more and more.
Yeah.
And so the long-term goal, we've put in cisterns to capture some of the water out of the stream and start using that because it's good, usable water. And so the long-term goal is that the only use for city water will be for drinking and cooking.
Yeah.
Right?
Yeah.
The stream and everything else we capture will handle all the rest of the loads in the building, move from a bazillion different separate mechanical systems to one central system in the building.
Yeah.
We did a year-long experiment looking at how to, because we've got windows that are 15 feet tall, what would be the best window configuration. So we did a year-long experiment and eventually came up with one that everyone liked and had both the performance and the daylighting characteristics that we needed. And so as the Google takes over portions of the building, then those windows are retrofitted into place. So it's ongoing.
Yep.
It's an ongoing process.
Bill, let's back way up. You're what a fascinating story. I think we're getting a lot of it, but let's back all the way up to just your definition of biophilic design, and then we'll want to get into how you dove into this space. But how do you define biophilic design?
So biophilic design is a process of very intentionally bringing experiences of nature into the built environment. And our reason for that is that what we've learned, and this actually started when I was at Rocky Mountain Institute, was that, the experience of the building really can have significant impacts on both your psychological experience, but also your physiological experience.
Yep.
And that translates into really big numbers. We at RMI, when we were all there, we were all focused on energy efficiency. And yet if I look at the annual cost of an office building, assuming that it's actually occupied right now, the thing we were all driving at was the energy cost.
Which is a fraction of the operating cost. Yeah, it's the people, right?
It's the people. Yeah, the people are more than 90% of the annual operating cost, right?
So if you can boost their productivity or make them happier, and however, I guess, right?
Exactly. And so that's actually, what started that was case studies that we were collecting at RMI for two different books. One that Joe Rome and his team were doing on energy efficiency in industry, and the other was on green buildings, the Green Development Service Group was doing. And so that resulted in the publication, Greening the Building and the Bottom Line. When Joe moved from RMI to the Department of Energy, he had some funding available to follow up on that paper. And so there was an opportunity where Herman Miller, the furniture manufacturer, was moving 700 people out of a windowless box into a new, beautifully designed daylit building done by Bill McDonough, surrounded by a restored prairie landscape. And so this was a good opportunity to see, does this, no changes in management, just move the people in and let it run for a year and see what happens with those people and the overall productivity. One of the three scientists that were brought in from the federal labs was an environmental psychologist named Judith Heerwagen, who's based in Seattle. And Judy is one of the original researchers on biophilia. And she said, I think, part of what we might see here is, if we see a gain in productivity, it may be this aspect, biophilia, which at the time, this was 1995, it's like, what's that word? And so we just, we started finding every paper we could on the topic. And what we eventually saw out of the study was that there were three different shifts, and there was an overall gain in productivity, but it was not consistent across the three different shifts. The daytime shift had a very big, significant gain in productivity. The data for the swing shift was messy, and the data for the nighttime shift was they did not get a gain in productivity. And the nighttime folks were in this beautiful, well-lit facility, but they didn't get the daylight and they didn't get the views to that surrounding landscape. Right. And so that sort of drove it home for us. And so that was the introduction to biophilia. So we've just, over the years, keep every paper we can find, we read and categorize by what's the experience of nature that people are having and what's the response.
And are you accepted? Is this commonly accepted now by architects, or are you still on the fringe, Bill?
So it's been among the top 10 design trends for hospitality design for about 5 years now. It is, we see the word biophilia appear in magazines and places all over without even a definition anymore. So I think it's out there.
Right.
I think most people think, I've got a potted plant, I have biophilia, right?
Yeah. Right. But it's a deep concept. I mean, we all sort of, all of us that have kids, we want our kids to be in schools that have windows, and that we believe that natural lighting helps them learn better. And then I guess that you uncovered studies for hospitals that, post-surgery patients in rooms that had windows and let in natural light and views of the natural world, they got better. I'm just wondering, with like the business sector, you mentioned hospitality, but what about office buildings? Is it still a challenge to get an office building owner to recognize that they'll have increased productivity if they design, in a way that's more biophilic?
So we have written biophilic design guidelines for Google, which they recently made public through Living Future. People can see those and download a public version of those guidelines.
Wow.
For their own use. We've worked with other tech firms. We've written biophilic design guidelines for hospitality brands. We have done post-occupancy evaluations of buildings with the Center for the Built Environment at Berkeley, and also with the Advanced Buildings Group at Carnegie Mellon, the School of Architecture, seeing how people are responding. So yeah, we are definitely, among our current projects, we've got 2 corporate headquarters, one for one of the biggest financial institutions in the country, where biophilic design is a major component of the focus of the experience they want to create for their employees and visitors. And so it's happening.
Yeah, that's great. That's great. Let's talk about, I think you wrote about 14 different patterns of biophilic design. And I was fascinated that, I want you to sort of elaborate on this, but you said that water, and I guess that would be like a water feature in a building, sort of helps people with their memory, and natural rock and wood has a different effect. Is that right?
Yeah. So what we did at collecting all those papers, we realized that we could categorize the experiences into sort of 15 different experiences. And they fell into 3 broad categories. So the first category is what we call nature in the space. And so those are direct experiences of nature in the built environment. And so that may be having a view to plants and animals and, and to a landscape, or even just paintings and photographs and pictures of nature. And so even just viewing a photograph of nature for 40 seconds can have an amazing impact. So one of the things that one of the underlying theories and sort of response to nature for a long time has been called attention restoration theory. And it's this idea when you're experiencing nature, your brain shifts processing mode. You move into this experience called soft fascination. And in fact, what we now know is that even just viewing a photograph of nature for 40 seconds causes the prefrontal cortex to quiet down. And so the brain is expending a lot less energy. And when you come back to be focused, you actually now have restored cognitive or enhanced cognitive capacity. And so that's one of the patterns is a visual connection to nature. We have lots of other senses, so we also look at other non-visual connections to nature. We look at variable daylight. We look at, which includes both changes in daylight and also the circadian change in color, temperature of daylight over the course of the day. We look at water, the presence of water. Water elicits a really, really strong response. It's calming, it's something that we respond to, and experiencing water visually, acoustically, being able to touch it, being able to taste it, all of which are really, really powerful. Water also has this unique, the sound of water has this unique thing that it does to us. So one of the areas we've been looking at is a field called psychoacoustics, which is the difference between acoustics. It tells you how sound moves around in a space, how loud it is, the reverberation and all that. Acoustics tells us what comes to our ear. It doesn't tell us what we're hearing. So the way I can explain the difference here between acoustics and psychoacoustics would be what's sometimes called the cocktail party effect. You're in a busy bar or you're in a party and you're having a conversation with your friend. The two of you are looking at each other and talking, and you're hearing what they're saying and they're hearing what you're saying. What you don't realize is that every other sound in the room is coming into your ear at the same time. We can't process all that. And somehow the brain is able to sort of pull out this one channel and focus on that one conversation. That's psychoacoustics. And what we've learned is that if I'm going to try to mask noise in a space, the most effective thing I can use is the sound of water, like a little waterfall or a small, well-aerated stream. And from an evolutionary psychology standpoint, that makes perfect sense. Think about being on the savannas of Africa, where humans evolved. There is not water everywhere, and not all of it's fresh. What's going to be the cleanest source of drinking water? A little waterfall or a small aerated stream. And so when we hear that sound, the brain will latch onto that and filter out almost everything else and focus on that sound. And so that's one of the powers of water. So, when you think about it, you're in the old Gion district in Kyoto, and you've got a busy street next to you, and you've got a little restaurant here, and right outside the front door is a little stone basin with water pouring into it, right? And so you've got cars going right next to you, and the brain goes, oh, look at this water, hear that sound, right? It totally shifts your entire frame of reference as you enter and come into that space, right? You focus on that, and everything else goes away. So those first set of patterns that I mentioned are this idea of direct experiences of nature in the built environment. The next category is natural analogs. And so these are indirect experiences of nature. And well, we had 7 patterns in that first category. In this one, we have 3. And these 3 are around indirect experiences. So one is biomorphic forms and patterns, right? And so these are shapes, patterns, numeric proportions like the golden mean, Fibonacci sequence, and things like that, that occur again in nature, that when we replicate in the built environment, the brain goes, yep, got that, know what that is, and responds very positively to them. You know, and if you think about architecture and fabric design and pottery and all that, we have flowers and leaves and animal, right? I've done that on for forever, right? The next category is the use of natural materials. We don't know why, but the brain seems to sort between alive and not alive very, very quickly. And so it may be one of those reasons why, you know, when you see that beautiful flower and you reach out and touch it and discover it's plastic, you're so disappointed, right? Because the subconscious had already told us it was alive, and we're not happy when the brain gets it wrong. And but you know, things like the use of wood. Wood elicits a really, really positive response over lots of other materials. And we think some of it may be because the brain does what's called semantic processing and goes, oh, look, wood, tree, alive. But it also is the pattern wood grain itself is a collinear pattern. And when you have a bunch of lines moving in the same direction, it's one bundle of neurons that processes that, and it makes it much easier and much quicker for the brain to process the image. And so having wood in the space like that, anytime it's easier for the brain to do stuff, that makes us happier and calmer. So then the next category is complexity and order, and this gets at fractals, which is another thing that occurs again in nature. And these are self-repeating mathematical patterns. In nature, they tend to be called what are called statistical fractals. So they're repeating patterns that have variations. So think waves on a beach. Think the pattern on a fern leaf, or flames dancing in a fireplace, or one of my favorites, the dappled sunlight in an aspen forest. And so we can recreate those mathematically. And what the neuroscientists tell us is that the brain is so attuned to those that when we see them in human designed objects, the brain goes, got that. And so literally the term the neuroscientists use is fractal fluency. The brain is used to that.
So interesting, Bill. Wow.
Now the final category is nature of the space. And so these are 3-dimensional conditions that we can experience in space that elicit very different responses. And we now know each one is processed in a different part of the brain. The first one is prospect. This is an unimpeded view through space. It's great for wayfinding, perceptions of safety, and opportunity. The next one is one of my favorites, refuge, right? So, you know, if you think about, you come into a restaurant and there are round tables in the middle, and around the perimeter are high back booths. Who wants the booth, right? Well, a lot of folks want the booth. Well, the booth is a refuge condition. My back is protected. I have a canopy overhead. And so that's a place. And if that booth is up on a sort of raised plinth and I have a view across the whole rest of the restaurant, now I have prospect and refuge together. Another example would be a classic craftsman bungalow, right? Where you've got the big front porch with the roof overhanging it. I come up 3 steps. I'm sitting there. I'm raised up. I can see all up and down the street. but my back is protected and I have canopy overhead. So that's prospect and refuge together. The other patterns in that category are mystery, which is sort of that, what's that view around the corner, right? I just got to go see what's around that corner. Risk peril, which is, standing, looking over that railing going, whoa, right? You're not going to fall, but it's a little exhilarating. Frank Lloyd Wright was really good at that one. He used that a lot. And it's funny, the Guggenheim Museum in New York, with that big spiraling ramp, you get to the top of that ramp and you want to look down into that atrium, and the railing is uncomfortably low. It's not unsafe, but it's at a height that when you see people looking over it, their hands are on it and their feet are back a little bit as they look over that edge. Risk peril. It elicits a strong dopamine response. You just don't want to use too much of it.
Hey, Bill, this has just been an incredible discussion. I am totally fired up. And I want to wrap up here, but where would you send our listeners if our listeners is as fired up as me? How do they get more of this? Where would you send them?
So we have a whole bunch of publications that people can download for free on our website, which is terrapinbrightgreen.com. Go to the publication section. You will see papers on fractals. You'll see one of our newest papers is an update of one of our original papers, which is the economics of biophilia, why it's important to do this and what the results are. You'll see 14 patterns of biophilic design. You'll see papers on wood. You'll see papers on the psychoacoustics of water. You'll find all sorts of resources, papers on designing with fractals. So you'll find all sorts of resources there. We also have a book that we did with the Royal Institute of British Architects called Nature Inside, a Biophilic Design Guide. That, unfortunately, you can't buy through our website. You'll have to go to Routledge or Amazon or the Royal Institute of British Architects, but that's available as well. And then I'd also, if you want to dig around and sort of get an introductory course on biophilic design or sort of design certification, you can do that through the International Living Future Institute, ILFI, to their website as well.
Fantastic.
And then if you want to dig further, one more.
Okay, one more.
We have, there's a new town outside of Atlanta, Georgia, called Serenbe. And a lot of the design of Serenbe is based on biophilic design and biophilic experiences. And so there is a conference there coming up at the end of March in 2024 at Serenbe will be the Biophilic Leadership Summit, which is an event that brings together designers, researchers, and others to have conversations about biophilic design.
Very good. Hey, Bill, thanks so much for your time today.
Happy to do it. Good to see you.
That's it. Thanks for listening to Flanigan's Ecologic. We'll see you next time.